First up is going to be Jason Doughty, the Director of Bridges for Majestic and Masters Raleigh office here. He's going to be talking about the preservation of 3 movable bridges in North Carolina. And as a former bridge engineer for New Jersey DOT, my job when I was there was to get rid of all our movable bridges. We had 32 when I started. We had 26 when I left. So Jason, why don't you come on up and we'll get started here.
Thanks, Dick. Thanks for the introduction. Yeah, everybody seems to want to get rid of movable bridges, so it's sort of a dual-edged sword for us because that's one of our specialties. So we love them, and I know some of us hate them. So today, thank you. I want to thank the NCDOT and the Southeast Bridge Preservation Partnership for the invitation to speak today. I know there's a jam-packed schedule today, so we'll do our best to kind of keep on track on schedule. So throw something at me if I'm taking up too much time. So yeah, we're going to talk about 3 recent rehab projects NCDOT had undertaken here recently for 3 of their movable bridges in the southeast part of North Carolina. So today we're going to have an introduction. We're going to go do an overview, kind of a high-level overview of those projects. We're going to offer up some key considerations for folks to think about as they may be forced to rehabilitate and keep their movable bridge fleet in service and reliable. And then maybe a little time, hopefully, for some Q&A. So let's, first from an introductory standpoint, the Southeast region in particular has an extensive amount of movable bridges. And so these projects, the preservation program for these bridges is important. It's a key ingredient to the overall program. And oftentimes these structures fall on key routes on our highway network, for either hurricane evacuation, military procedures and operations, just shipping goods and services across the state. So oftentimes these are key and vital routes that have to have reliable structures on them. And then when we talk about movable bridges, reliable operations is a key point of discussion always. And yeah, we hate to talk about this, but they're high-value structures. They cost a lot of money to replace. They cost a lot of money to rehabilitate, and that's why it's so important to have a plan in place to preserve these structures. And sometimes they're not able to be replaced with a high-level fixed span, so it's just the geometry and the lay of the land may require them to stay for years to come. So let's move into these 3 projects. All 3 of them are located in the Wilmington region. They all were what I'll call comprehensive rehab projects, meaning the fixed spans and the movable spans were rehabilitated. There were mechanical, electrical, and structural upgrades. So that's what I mean when I say comprehensive. All 3 of those projects had those same components. The goal really was to plus or minus extend service life about 25 years. That's the idea. Sometimes things end up breaking and need to be repaired and fixed a little bit sooner than that, but that is the objective for each of these projects. And I think in the Southeast region particularly, we have an appreciation for storm resiliency. We've seen a real increase in the frequency of these strong storms, and the movable bridges from, again, the operational reliability standpoint, the weather and those storms play a role in how those facilities are affected and how they affect the highway network. So the 3 projects in specifics, we rehabilitated the Cape Fear Memorial Vertical Lift Bridge, then the companion project just to the north at Isabel Holmes, and back in 2011, but then more recently in 2018, a rehabilitation at Wrightsville. 2011 was the more comprehensive version. What we're going to spend a little time on this morning is what happened in 2018, which was kind of a deck modification style project. So let's launch into the Cape Fear project. In case you're not familiar with the region, the bridge is located in Wilmington. It spans the Cape Fear River. The total bridge length, including fixed and movable span, is about 3,000 feet. It carries 4 lanes of traffic, and the lift span is a 408-foot through truss. When the bridge is opened, it provides 135 feet of vertical clearance over the channel. and the horizontal opening is 350 feet. Bridge was opened in 1969. So from a service life perspective, you can kind of get a feel for where we are with this structure. The scope of work for the project is listed there on the slide. Grid deck, a handful of structural steel repairs. Back on the approaches, we're talking overlay, joint rehabilitation, joint replacement, some cleaning and painting, mechanical and electrical upgrades, and some tender house improvements where the focus was trying to get that thing watertight as best we could. Project was let in 2018. There were 4 bidders. You can see the kind of the breakdown of the bids there. $13 million. I mean, that's a pretty healthy rehabilitation project, and as Dick alluded to, they're not inexpensive rehabs when we get into some of these projects, but they're intended to last a while. So the idea is hopefully there's some bang for the buck. Let's get into some of the construction details, and we'll try to do this kind of on an overview, kind of key items. Grid deck replacement. We're going to focus a little more attention on this a little bit later in the slides. But the existing grid deck was removed and replaced. You can see how the contractor cut out the existing panels, and then there's a stack of new panels there on the right. Traffic control, they only were able to remove and replace as many panels as they could in a shift because the bridge had to be reopened to traffic the next morning. So it was kind of from a traffic control perspective, that's a key ingredient when looking at the grid deck replacement operations. Moving on, there was, on this bridge, there was a single tube median railing that was replaced and upgraded, another enhancement that the DOT had been wanting to do, and this was on the fixed spans as well as across the lift span. A variety of steel repair details, stringers. An open grid deck is not very forgiving to your floor system, and so there's a lot of repairs to be done oftentimes on the stringers and floor beams. On this particular bridge, we also had the classic web gap situation from a fatigue standpoint. We had to retrofit the floor system to mitigate that, along with some crack arrest holes and those types of things. Bottom cord members, towers, so it was really a broad mixture of steel repairs. Moving on to the fixed approach spans, we did a polyester polymer concrete overlay, PPC. DOT's been having some good success with that system these days. Foam joints, I think I got a chuckle out of that photo. You never know what you're going to find in an old bridge deck joint. That was not a new joint, by the way. That was one that was going to be replaced. One other interesting detail is that there was a misalignment vertically at the finger joint on the end of the lift span that needed attention. And so the design drawings showed details for repositioning that deck, that finger joint to kind of take that little bump in the road away. So that's a high-level overview. I want to hit that. That was for Cape Fear. We're going to do the same for the Isabel Holmes real quick. Again, located in Wilmington, crosses the Northeast Cape Fear River, 2,300-foot long bridge, 4 lanes again. This one is a double-leaf bascule bridge. Provides 200 feet of horizontal clearance, and was opened in 1980. This actually was an original Majeski Masters design back in the late 70s. So it's always enjoyable to go back to some of those old plans and calculations from back then and kind of enjoy looking through the archives. Scope of work, quite similar to what we had at Cape Fear. And by the way, just to mention, M&M served as the EOR for all 3 of these projects and also provided engineering support services during construction. So we were kind of in it from all the way through the construction phase. Back to the scope of work at Isabel Holmes, similar to Cape Fear, grid deck replacement, joints. Here in lieu, instead of an overlay, we were looking at a sign lane sealer for the fixed approach spans. We did cleaning and painting of the bascule span girders and floor system. There was some cathodic protection that was incorporated into the project. Again, mechanical and electrical upgrades. One that comes to mind was some addition for counterweight capacity. And then also, again, tender house improvements focused again on storm resiliency. So this project was let 1 year later from Cape Fear. There were 5 bidders on this project, and you can see the cluster of the bids. So deck replacement, now we're going to get into some of the construction details again. At Isabel Homes, there's an open grid, but also a fully filled grid as well. Both of those sections were replaced on this project. Joints again and deck sealer. The classic foam seals were used for most of the joints on the fixed spans. Now this photo kind of shows, the other photo for Cape Fear showed some of the repairs. This kind of shows you what some of the deterioration looked like in terms of pack rust, crevice corrosion, immediately underneath the grid deck. So again, you can see how the open grid isn't all that forgiving in terms of longevity sometimes for the floor system. So a slew of steel repairs that went along with mitigating these defects. One key item to think about from a cleaning and painting perspective, oftentimes we have to have accommodations for being able to open the span even when the bridge is rigged for cleaning and painting. And so there were details in the contractor shop drawings and in terms of the sequencing and how to accommodate a bridge opening. So that was sort of interesting, something just to be aware of. That's usually something that has to take place. I mentioned cathodic protection. We like to call them in our office the hockey pucks. I think we all know what that is, the cathodic galvanic anodes. We also used a field-applied metallizing on some of the concrete girder repairs, which I think the NCDOT has been trying that out on a few projects, and from what I understand, it's been successful thus far. I think the specification has been evolving with time, and I think it's, as far as I know on this project, things went quite smoothly. Kind of getting away from some of the structural details at Isabel Homes, replacement of the submarine cables was part of the scope of work. And so this is, again, something we'll talk about in a few minutes, but you can see it's kind of a different operation altogether than what we're talking about with steel repairs and cleaning and painting. So now we're going to jump to the Wrightsville. Now, this is one where, again, in 2011, there was a similar comprehensive style rehab project. But what we'll talk about here is more geared toward a recent grid deck modification. So Wrightsville, existing overview of the bridge, again, located just east of Wilmington, spans the intercoastal waterway, total bridge length of 731 feet. 4 lanes of traffic, and a key point is it carries the river to the sea bikeway. A lot of bicycle traffic on this structure. It's a 170-foot double-leaf bascule and provides 90 feet of horizontal clearance, and then unlimited when it's open. Built in 1956, so again, we can kind of get a flavor of service life given that we're in the year 2022. So this was interesting. There was a desire to create a more bicycle-friendly grid deck in the shoulder. If you think about the classic open grid deck, the 4-way, typically 5 inches and change deep, with some of the bicycles, I guess, I'm not a bicycle guru, but some of the tires are quite skinny. And I understand that it can be a little bit challenging to maneuver over the diagonal bars in particular when you're going across the open deck. And so there was a desire from the local community, and the DOT responded to provide a modification to the shoulders. And so essentially a type study was done to evaluate a few different alternatives, which included a partially filled grid. In other words, fill what's there with concrete to create a smooth traveling surface on the top. We looked at some kind of perforated plate alternative. And then we also studied what was actually built was the tightened up supplemental bar spacing configuration. Now, interestingly, on the surface, all of those seem reasonable from a structural perspective, but the idea was to minimize the impacts to the machinery and some of the other mechanical components, particularly counterweight and balance. And so the sweet spot really was this alternative that was built with the closely spaced supplemental bars. So that creates a very tight spacing of bars that are perpendicular to the axis of the bicycle, if you will. And so it creates a much safer environment for the users of the shoulder. So that was the nature of that project. A little bit different, but something, again, for those who have movable bridges in their inventory with open grid that may have high bicycle usage, something to think about and keep in mind. So let's kind of step back a little here and talk about some key considerations for these projects. Scoping inspection, this was a task that was done for the Cape Fear and the Isabel Holmes, and they really set and shaped the project. I think when we go into these, we get the idea that we're going to do cleaning and painting, we're going to do steel repairs, but sometimes we need to go a step further and really get a taste of what these steel repairs may end up looking like, for instance. And so when you go out and do those inspections and tabulate what really needs to be done, that is very useful to the owner as the plans and specifications become more reality in terms of getting them going. And the last bullet, it seems trivial sometimes, but to have an eye for what repairs may look like when you're in the field looking at these things goes a long way. We beat our guys over the head to say, make sure you think about what you're going to be doing from a repair perspective when you're out there looking at all these things. And I think of a story when we were doing a large bridge gusset plate load rating assignment, and I was hanging in a UB60 basket in the middle of February at 3 o'clock in the morning, and I think it was the coldest I've ever been in my life. And I thought to myself, I want to make sure I get every piece of information I need because I'm not coming back out here. So that's the idea, is that have an idea of what you need going into it, and it'll make the effort smoother when you're back in the office working on the plan development. So grid deck replacement. A lot of the grid decks that we see out there look awfully similar, but there are subtle differences that need to be really kept in mind. And this is really when it gets to span balance and evaluating machinery. Some of the nuances from a self-weight standpoint is coating. Sometimes the old original grid maybe was not galvanized, and maybe it was painted at the time or something, and so there could be a difference. And it sounds small, but it could become 2 to 3 to 4 pounds per square foot, which, as that accumulates and we look at machinery and span balance, it makes a difference. One interesting thing, too, is back in the late 90s, and I say this because some of the bridges that we're talking about are in this vintage, is that there was a change to the grid deck standard details where they modified to accommodate some fatigue performance, poor fatigue performance that they were experiencing. And so the crossbars deepened by about 1/2 inch. And if you're walking out on a grid deck, you would not really recognize or know that. And so it's really important to field measure those bars, because oftentimes, as was the case at Cape Fear and Wrights and Isabel Holmes, is we wanted to match the existing self-weight as much as we could. And so that's something to keep in mind as you're looking at possibly replacing grid decks on your bridges. The last thing is BGFMA. There may be a quiz at the end of this session, so BGFMA, the Bridge Grid Flooring Manufacturers Association, excellent resource. They probably know a lot about your bridges already, and so a good resource if you need. Like I said, span balance, keeping the weight of the new grid, and the steel repairs, the weight of the steel repairs have to be incorporated into that balance. Last thing to mention is some of the mechanical and electrical components can be antiquated, and you can't just go down to Home Depot and find a new motor. A couple other quick things. I know we're running tight on time here. These are non-bridge engineer type ideas that we need to always keep in mind. Submarine cables, that require some permitting coordination. So in the case of Isabel Holmes, the Army Corps of Engineers was the permitting folks that we needed to be paying attention to. Coast Guard always is in the equation on these projects because oftentimes we're going over navigable waterways. Storm resiliency, again, the picture there on the left is the new backup generator at Isabel Holmes that's onshore, set up above flood elevation. So again, storm resiliency kind of becomes a theme again. Last thing, I love this slide. The photos on the left are 1970s vintage movable bridge equipment. Pinion shaft gearbox on the left. On the right is a bridge that was built in the 1890s that is open gearing and is in outstanding condition. And we talk about the importance of reliable operation of these movable bridges. And if you create a preservation plan, work the plan, you're going to have reliable operation and service for years to come. And this is a good example of that. I don't know where the bridge on the left is. Even if I did, I'm not sure I'd reveal it. But the one on the right is out in Illinois, actually the government bridge. So with that, I just wanted to say that it's doable. We can maintain these things, and they can be reliable for years to come, and that's really the goal. So with that, I'll open up if anybody has any questions, and thank you for listening.
Thanks for your presentation, Jason.
Sure.
If you could just elaborate on the fatigue details at the Cape Fear Memorial Bridge. You said you had to drill some holes and things like that?
Yeah, there was a cracked, forgive me, this was about 3 years ago, but it was a cracked stringer web, and the stiffness of the stringers near the median they're bigger stringer sections than in the roadway, and there was only a partial height connection plate, and there were cracks in the stringer. And so we introduced a full height connector plate there, and we repositioned the diaphragms to alleviate that hard point, and then also drilled the crack arrest holes at the crack locations that we had.
Thank you very much.
Sure, thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.